Thank you, Johnny. Thank you, everyone, for being here. Hi, I'm Alex, the founder of 3DK Tech, and we're breaking down the barriers of metal 3D printing. Well, what's metal 3D printing? Basically, we take some metal powder, very fine, we add it on a metal substrate. We can play the video, please. There we go. And we use a laser to selectively melt a section of the 3D object. We repeat that process several hundred to several thousand times, and then we end up with a finished product, 3D object. This is from our own MVP. So, why metal 3D printing? Well, it's simple. There's a lot of benefits to it, one of which is improvement in time to market. In the example on the screen right now, you can see a jet fuel injector. The turnaround time for that part was reduced by 10 times. And that's partly because you're able to reduce the number of components from 150 to just 2. The market itself knows that it's a great technology, and the CAGR has been over 50% in the last few years and is expected to continue at least 35% over the next few years. So, what's there to break? There's 3 issues that we've identified. Inferior mechanical properties, long manufacturing times, and there's only a handful of metals available to print. And we're solving all 3 of these issues with our hardware-software solution, ultrasonic selective laser melting, where we give full control of mechanical properties to our customers, reduce manufacturing times by up to 60%, and provide a virtually unlimited choice of printing metals. Let me break it down a little bit more. So when you 3D print something, you don't have great fatigue, durability. So you have to go through some extra steps after the fact to reach the fatigue level required for functional components. And with our technology, we're actually able to reach that point without having to go through the extra steps. That makes our technology 200 times more durable. In economic terms, that translates to reduction when compared with our competitors. If we skip all of these extra steps, we can reduce the manufacturing time from 1,200 hours down to just 300 hours, and the manufacturing cost of $56,000 down to just $6,500. And this is an example of a compression blade assembly. So that's in the jet engine, that's a compression blade. So we're talking about aviation. Obviously, that's our market. That's our first market. We've identified and calculated it at $3.3 billion. Our secondary market is going to be the automotive at 4.7. And the way that we're addressing this market is we've already started. We've been working with HAECO, the largest Asian aircraft maintenance and repair operations, with a $1.5 billion revenue in 2019. And we're talking with them to identify the steps in which they can start integrating 3D printing into their supply chain. We're starting off with printing tools, specialized tools that they already need to use. Then we'll be getting certification and start selling these parts to them and their partners. Down the line, we have a roadmap to start printing other functional components within their aircraft, eventually getting into critical functional parts such as those in aircraft engines and so on. Our end goal is to start selling 3D printers to them and building a reputation of good quality parts to get to that point. There's another big important element of metal 3D printing, and that's sustainability. I don't know how many of you know this, but 20% of the entire global greenhouse gas emissions are caused by manufacturing. When we compare conventional manufacturing with metal 3D printing produces 20 times less CO2. Not to mention, 3D printing uses 10 times less materials and less energy to produce the same part. And 3DK Tech has actually been recognized as one of the world's top 1,000 global solutions fighting for ecological future, a sustainable future. Where are we right now? Well, we finished assembly calibration, testing of our MVP, and we're finishing with our optimization soon. This is the process happening within our own machine. And so was the first video that you saw at the beginning. 2020, we started assembly of our MVP. We launched our metal 3D printing service, so we've started generating some revenue. 2021, we finished assembly of our MVP. We raised a pre-seed with Johnny and the E Fund, got incubated into Science Park, started working with HKO and a few other partners. 2022, we'll be doing a seed fundraise, and 2023, we plan on launching our metal 3D printers. Our monetization starts with 3D printing parts, goes into sales of metal 3D printers starting 2023, at a BOM of $215,000 US and a selling price of $500,000 US. Further down the line, we'll do hardware as a service. We expect a revenue of $80 million US by 2028. Our team is very important and very experienced in this. I am one of the inventors, have a PhD in mechanical engineering. I've trained all the engineers that are working under us, and our business development people have executive MBAs. Olivier has 25 years experience in procurement and manufacturing, and Olivier, 12 years in aviation. Our advisors are top-of-the-line professors and entrepreneurs. So, 2022, February, we'll start our our seed fundraising. We'll raise $2.5 million US. With that money, we'll build our first generation commercial 3D printer, develop control software with intuitive GUI, and launch products with our partners like HKO and others, and get certified. Thank you.